This is a practice problem from the topic lumped analysis from the module 1. Let me read the question. A 50 centimeter copper slab of 6.25 mm thickness has a uniform temperature of 300 degrees Celsius. Its temperature is suddenly lowered to 36 degrees Celsius. Calculate the time required for the plate to reach the temperature of 108 degrees Celsius. The given data are density is 9000 kg per meter cube and the Cp is 0.38 kJ per kilogram degree Celsius and thermal conductivity K is 370 watts per meter degree Celsius and heat transfer coefficient H is 90 watts per meter square degree Celsius. Here is all the given data: density, Cp, thermal conductivity K and heat transfer coefficient H. This is the basic equation from this topic. By hearting this equation we can solve almost all the problem from this type. This is equation T minus Ta by Ti minus Ta is equal to e raised to minus Has divided by rho Vc into tau. Let me explain all the terms. T is the temperature of the body at any time. Ta is the ambient temperature. Ti is the initial temperature. Ta is the ambient temperature. E raised to H is the convective heat transfer coefficient. As is the surface area. Rho is the density of the solid. V is the volume and C is the specific heat and tau is the time. This equation is also available in the data book also. The above equation can be used only if the value of Biot number is less than 0.1. Biot number can be calculated by the equation HLC by K. H is the convective heat transfer coefficient, L is characteristic length and K is thermal conductivity coefficient. And LC can be calculated by, is the equation for LC is volume by area. Volume we know, volume length into breadth into height. 0. We get 0.0015625 and surface area is it is just 50 mm into 50 mm on both sides, 2 into 50 mm. 50 mm is 0.5 into 0.5. We get the answer as 0.5. We get the value of LC as 0.003125. By substituting in that equation we get H it is given as 90 into LC divided by thermal conductivity coefficient 370. We get Biot number as 7.6 into 10 raised to minus 4, which is less than 0.1. So we can use that equation. In the question it is said that calculate the time required for the plate to reach the temperature of 108 degrees Celsius. So therefore T is 108. And the question also said that suddenly it is cooled to, so that is the ambient temperature, that is 36 divided by initial temperature is also given 300 minus ambient temperature is equal to e raised to convective heat transfer coefficient H, which is given as 90 minus 90 into surface area we have calculated as 0.5 divided by density is given 9000, volume we have calculated, and specific heat is given, it is given as kilojoule, so we have to convert it into joule into tau. 108 minus 36 divided by 300 minus 36 we get 0.2727 is equal to, by solving all that we get e raised to minus 0.00842 tau, and that e raised to minus 0.00842 tau can be written as 1 by e raised to 0.00842 tau, and we rearrange that e raised to 0.00842 tau is equal to 1 by 0.2727. Taking log on both sides we get 0.00842 tau is equal to ln 3.667. tau is equal to that ln value, ln 3.667 is 1.2994 divided by 0.00842 is equal to 154.32 seconds.